Hey, good morning, guys. Today we're doing the product to sum identities. These are at the bottom of that sheet that I gave you at the beginning, but all of these identities are up here. So it's what it sounds like. Product means when you multiply, sum means when you add. So sometimes it'll be beneficial to switch between the two. Now, they only really give us 4 different options here: sine times sine, cosine times cosine, sine times cosine, and cosine times sine. So see how there's no tangent or anything? We're just going to work with these 4. Okay, so in the directions, all it says is rewrite each expression as a sum or a difference. So this first one, so we've been using theta to represent our angle. On this worksheet, they're using different variables. They're using x's, but same thing. We have sine of 3x times cosine of 2x. So you have to look for that pattern. Sine times cosine. So if I look up here, it is this one right here, sine times cosine. And we have this pattern that we're going to follow. So the first angle would be A and the second angle is B. So for us, that 3x is going to be A and that 2x is going to be B. So other than that, we're just going to follow this pattern here. So we have 1/2, then it has square bracket, sine, parentheses of A plus B. So 3x plus 2x. I'm getting that from here. And then I'm continuing this pattern, plus sine of A minus B. So parentheses 3x minus 2x. And then close those square brackets. Okay, now we simplify this as much as we can. So I'm going to leave this 1/2 here and the bracket. But that first one, sine of 3x plus 2x, when we add those together, gives us 5x. And then plus sine, over here, 3x minus 2x is 1x. So you just need to write the x. You don't need to write the 1. Close the bracket. And then one more thing we could do to simplify is this 1/2. We can distribute it to both of these terms here. So this would turn into 1/2 sine of 5x plus 1/2 sine of x. And that's our answer. So we got this product here, and we were able to turn it into a sum. Okay, let's look at the next one. The next one says sine of 4 theta times sine of 7 theta. So this one is double sine, sine times sine. So when you look at your patterns up here, sine times sine is this top left. So we're going to follow this formula, this recipe here. So we have A and B represent the first and the second angle. So I'm going to go ahead and label that. 4 theta would be A, and 7 theta is B. But now we're going to follow this here. So it also starts with 1/2 and then square bracket, but this time they're using cosine. So 1/2 square bracket cosine. Okay. Then it has A minus B. So it'll be 4 theta minus 7 theta. Close that. Okay, then if I follow here, it's minus sine, then cosine of adding those angles. Okay, so minus cosine of A plus B, so 4 theta plus 7 theta. And then close those square brackets. So this is like number 1, where all you have to do is really go through and simplify everything that you can. So I'm leaving that 1/2. But this first term, 4 theta minus 7 theta, that gives us a negative angle. That's negative 3 theta minus cosine. Then over here, 4 plus 7, that would give us 11 theta. Okay, so just off to the side, I'm going to write something. So we don't usually like when this happens, when there's a negative angle inside of the parentheses here. So if I see negative angle, my thoughts go to the even odd identities. So one of the even odd identities says that cosine of negative theta is equal to, well, actually I could just show you, that way you can believe me. So even odd, here's cosine. So cosine of negative theta is equal to just cosine of regular theta. So all that really happens is you can take off that negative sign if you want to. So like I said, we don't really like negative angles, but this even odd identity tells me that I could just take that off. So I'm going to highlight that orange. That way y'all know where that's coming from. And then the other thing we're going to do to simplify is distribute the 1/2 to both things. So now I'll have 1/2 cosine of positive 3 theta because I'm using this even odd identity over here. So I just took off that negative sign. And then minus 1/2 of cosine 11 theta. Okay, we're going to do another one just like that. So negative 14 cosine of this right here is an alpha times cosine of 5 alpha. So that negative 14 in the front doesn't really mean much. It just means you're multiplying by those two things. So I'm going to have that negative 14 no matter what I do. But this cosine alpha times another cosine, when I look at my patterns, let's erase this one. It's now the second one, cosine A times cosine B. So this is the pattern we're going to follow. Really similar to the one above. Like if I'm looking, it's almost exactly the same. The only difference I see is this plus minus here. So like we did before, we're going to put times, because whenever we have 14 just in front of something, that means times. We're going to fill in that pattern. So 1/2 alpha is A and 5 alpha is B. So square bracket, cosine of alpha minus 5 alpha. It kind of looks like a fish when you draw it. Let's make sure I'm doing this right. Yes, it subtracts. Then plus sign of cosine of adding them. So plus cosine of A plus B. So alpha plus 5 alpha. Okay, so to simplify a little bit, let's actually multiply these two together. 14 times 1/2 is negative 7. Then let's do all those angles. So alpha minus 5 alpha, again, is negative, so negative 4 alpha, plus cosine. Over here, alpha plus 5 alpha is 6 alpha. Since we already did this up above, anytime you have a negative cosine angle, you could just take the negative off. So that's what we're going to do. We're going to take the negative off. But also this negative 7 needs to get multiplied to each of these terms. So negative 7 times cosine 4 theta is just that. But then now I have negative 7 times cosine of 6 alpha. So this, I know it was positive, but since this is negative, it's now going to be minus 7 cosine 6 alpha. Okay, so those are our first three where all we did was rewrite the expressions. Okay, the next two, the directions are a little bit different. It says, find the exact value of each expression below. Anytime you see the words exact value, you're going to have to use your unit circle. So for these here, use the unit circle. So I do have my unit circle. I put it here, that way we can refer to it. We are going to need that in a little bit. But let's see what we have. We have cosine of 195 times the sine of 135. So I know for a fact that 195 and 135 are not on the unit circle, but maybe their sum and difference will be. So the pattern here is cosine times sine. Cosine times sine. So when I look up here to my identities, we need to find cosine times sine, which is this one here. So A is the first angle, B is the second angle. This is the formula, this is the recipe that we need to follow. So it starts with 1/2 square bracket of sine A plus B. So for us, A is 195 and B is 135. So 1/2 square bracket of sine, I already forgot, let me look, of sine A plus B. So 195 plus 135. Okay, then let's look at the rest of that. Then minus sine of their difference. So subtract sine of 195 minus 135. Okay, so let's simplify this a little bit. So I'm going to keep this 1/2 sine, but let's actually add these two together. 195 plus 135 gives us 330. Subtract sine, and now this part, 195 minus 135 gives me 60. Okay, so now sine of 330 and sine of 60, those are on the unit circle. So I'm going to write down my 1/2 and then my square bracket here. But let's go and find sine of 330 degrees. So 330 is right here. So that goes with these. Now we want sine. So sine is that second one, negative 1/2. And then while I'm here, let's also find the sine of 30. I'm sorry, it was 60. So here, square root of 3 over 2. So negative 1/2 and square root of 3 over 2. Those are the two numbers we need. Negative 1/2 minus square root of 3 over 2. Okay, so now let's simplify that inside. The good thing is that they already have the same denominator, so you could just make it one giant fraction, negative 1 minus the square root of 3, both of them over 2. But then now you have this fraction on the outside times this fraction on the inside. Multiplying fractions is a lot easier because you could just multiply straight across. So if I look at the numerators, anything times 1 is going to stay the same. So it's going to stay negative 1 minus square root of 3. Then looking at the denominators, we have 2 times 2, which is 4. So this would be our answer. All right, and let's do that last one there. We have negative 8 of cosine pi over 4 times cosine of pi over 12. So just to make it a little bit easier, let's think of it as degrees instead. So keep the negative 8, parentheses, cosine. pi over 4, so I'm going to look at my unit circle. Here's pi over 4. That's the same thing as 45 degrees. The other one that we had was pi over 12, and there is no pi over 12. It would have been somewhere around here. So if you do your conversions, pi over 12 is actually 15 degrees. So here, this would be cosine of 45 times cosine of 15. Just makes it a lot easier to think of it in degrees. So 45 is going to be our A, 15 is going to be our B. We just got to go and find the pattern for cosine times cosine. So up here on the top, cosine times cosine is this one here. We're going to use this one. So it starts with 1/2 of cosine and subtracting those angles. Okay, so here's the thing with this one. It starts with a -8. So keep that -8, but it's going to be times 1/2 cosine of 45 minus 15. And if you continue the pattern of that one, it had a plus cosine of their sum, so 45 plus 15. -8 times 1/2 is -4. Then 45 minus 15 is 30. 45 plus 15 is 60. So those are the two angles we're going to need to find. Cosine of 30 and cosine of 60. So let's go and find those. So unit circle. Here's 30 and here's 60. And we want the cosine. So square root of 3 over 2 and 1/2. Okay, so square root of 3 over 2 and 1/2. Okay, so keep that -4 on the outside. But since those fractions both have the same denominator, we could just make it one giant fraction. So I put them together. And then we would want to multiply by that -4. Remember, whole numbers have an invisible 1 underneath. So you could do this thing where -4 can be divided by 2, and it now becomes a -2. Then multiply it in. So notice that the denominator is gone now, like we eliminated it. So we're only going to have a numerator. -2 times the square root of 3 is -2 square roots of 3. And then -2 times 1 is -2. Okay, and so those bottom two, we're finding exact values. If you really want to check your answer, you can type into your calculator this here. And then in your calculator, type in this, and these should be the same decimal. Same thing with that first one. This and this should be the same decimal when you type them in. Okay, and that's it for today's notes. This paper, please don't lose it, because tomorrow we're going to go over the back and there will be an assignment. Hey, just let me know if you have any questions.